I'm going to give you a quick walkthrough of how you can use the power of Kubecost combined with the power of Armory in order to decrease risk while saving money on your Kubernetes containers. So here I am in Kubecost, and as you can see, I've got $124 per month of savings just by right-sizing my container requests. In order to do this, I'm going to hop over to my GitHub Action workflow where I am currently deploying my application, and I'm going to go ahead and run this right-size my deployment workflow. What this workflow is going to do is it's going to reach out to Kubecost, query its APIs to find out what size Kubecost believes the containers should be. It's then going to deploy those new sizes using Armory's new Continuous Deployments as a Service offering, Project Borealis. While deploying, we're going to make sure that the integration tests work in staging, and then after deploying to staging, we are going to use a canary deployment in production to ensure that our environment stays healthy during deployment. Here we can see our deployment started, and we can open that link in order to view the status of this deployment within Armory's UI. Here we can see a simple overview of which environments are deploying, and we can see that our staging environment just finished deployment. We're now running our integration tests in this environment, and when they pass, we will start deploying our production environments. Our integration tests have passed, our production environments are starting, and as I mentioned earlier, they're using a canary deployment strategy. I can click into those environments to see the detailed status behind those deployments. A canary strategy slowly and incrementally increases how much traffic is reaching the new software version. So right now you can see we've spun up one pod on the new version, and we're spinning the old version down to 4 pods. While we are running this strategy, we will be running an automated canary analysis that is querying our metric provider, in this case Prometheus, in order to check whether our CPU and memory usage remain healthy. As you can see, we have finished scaling traffic to 25%, so we're now checking our CPU usage and memory usage and making sure they stay within our expected thresholds. Our first run of our automated analysis has passed, so we're now increasing traffic to 50%, and when that finishes, we will run another automated analysis. If at any point any negative impact is detected by the automated canary analysis, the system will roll back this change, thus mitigating any impact of the change of container size. As you can see, we've finished increasing our traffic 50%. We're now running our automated canary analysis again. In a few moments, we will see whether or not everything still appears to be healthy, and if things are healthy, we will finish rolling out the new version using the new sizes that came from Kubecost. However, if any issues that were not expected are detected, then the system will instead roll back. As you can see, our second automated analysis has passed, so we are now going to finish rolling out the new version, and then we will shut down the old version. This ensures, for example, that if your application needs additional resources during startup that were not needed during the time period that Kubecost analyzed, that it doesn't result in any problems during your deployment. Throughout this entire process, our deployment and application health were both being monitored, and if any issue had been detected, we would have automatically rolled back instantly. We also ensured that all of our integration tests were able to pass with the new sizing, thus ensuring additional safety in the new production version.